Hello and welcome to week 11, lesson 1. We're going to graph functions today. Uh, Hopefully by the end, you'll be able to determine the shape of a graph before you even graph a function. And then you'll be able to graph linear, quadratic, and absolute value functions. To graph, you need to understand what an ordered pair is. So an ordered pair is just an input and its related output written in parentheses in a specific order, with x coming first and y coming second. This can be placed on a coordinate plane. So with a coordinate plane, you remember you have an x-axis, which is the horizontal axis, and a y-axis, which is the vertical axis. 0, 0 is in the middle. It's called the origin. So here's a table, and we're going to plot these points. If the x-coordinate is negative, that means you go left. If the x-coordinate is positive, that means you go right. If the x-coordinate is 0, that means you stay right where you're at, right in the middle. With the y-coordinates, if it's positive, you go up. If it's negative, you go down, and if it's 0, you stay on. You don't go up or down, you stay right in the middle horizontally. So -4, 3 would be left 4, and then up 3. So you'll see a point right there, -4, 3. 0, -2 means I go left and right 0, and then down 2. You get a point right there. 2, -2 is right 2, down 2, and then 5, 5 is right 5, up 5. And there's plotting coordinates. And we're going to be doing that as we make these graphs from these from these functions. Being able to identify functions from their equations is important. All right. And the way you can tell is by looking at how the x is being changed. So a linear function, you'll see a multiplying or dividing of the variable. So an example here is 12x minus 4. You can see that the x is being multiplied by 12. A quadratic function is where you square the variable. So an example here, -3x squared plus 29. So the x is being squared. The absolute value function is where the variable is inside the absolute value symbols. So you see this one here. The variable is inside the absolute value symbols. All right. Now let's take a look at the next several slides are looking at how the function relates to the table and then how the table relates to a graph. So let's go ahead and get started here. The very basic linear function is f of x equals x. So we make a table and we get to choose our x values. And so when we choose our x values, it's more often than not, what we want to choose is -2, -1, 0, 1, and 2. And we choose that because we want to see what's going on to the left, it's the negative x's, and to the right, which is the positive x's of 0. And then we also want to see what's going on in the middle. To figure out the y values, we simply take the x value and put it in for x, and we're evaluating those functions. So f of x, or f of -2, equals -2. So the y value is also -2. For -1, it's -1. For 0, it's 0. For 1, it's 1. For 2, it's 2. This one's a very basic one because the x value matches the y value. Now we're going to take those points and put them on a graph. So -2, 2, you can see it plotted right there. -1, -1, 0, 0, it's right in the middle, 1, 1, and 2, 2. And what do you see? You have a discrete graph right now, but this is not a discrete graph. This is actually a continuous graph because I could choose x values that are between 0 and 1 or between 1 and 2, and I could get a y value. So I want to draw a line between those dots and make sure you put an arrow. All right, so it is important to add arrows to your line to show that the function extends into infinity. So it doesn't just stay on this graph, it goes on forever in both directions. And this line is actually an increasing line. It's going uphill as we go from left to right. Let's take a look at another one. So linear, again, this is linear because x is simply being multiplied by -3. All right, so I'm going to take -2 and put it in for x. So -3 times -2 gives me 6. 6 minus 1 is 5. And I've already had this set up, so I just want to show you that that's how you get the y value. I'll do another one real quick. -1. -3 times -1 is 3. 3 minus 1 is 2. -3 times 0 is 0. 0 minus 1 is -1. And you see the y values that you get there. Now let's put those on the graph. So -2, +5 is here. -1, +2. 0, -1. 1, -4. and 2, -7. And you see they form a line. Now this line is going downhill as you go left to right. So that we call this a decreasing line. So, so that's linear functions. Now let's take a look at quadratic functions. And remember, that's when x is squared. All right, so that's the very basic quadratic function. As we come up with our table, again, we're going to choose -2, -1, 0, 1, and 2. Plugging those in, -2 squared is +4. -2 times -2 is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And when I graph this, -2 +4, -1 +1, 0, 0, those do not form a line. You see, it's kind of curving. Okay, and let's continue. 1, 1, and 2, 4. If I connect those with a line, it makes a U, and that U is actually called a parabola. And we'll talk more about that in semester 2. This parabola specifically opens up. The arrows are pointing up. Okay, another quadratic, -2x squared plus 3. If I take -2 and plug it in, -2 squared is 4. Then I multiply that by -2. So -2 times +4 is -8. -8 plus 3 is -5. -1 squared is 1. -2 times +1 is -2. -2 plus 3 is 1. And you can see that you get all those y values when you plug in those x's. And if you plot those, you get a u, but this one actually opens down. And the reason it opens down is because of this -2 in front. If you're multiplying your x squared by a negative, it's going to switch the parabola and open it down. All right, so we've done linear and we've done quadratic. We're going to finish up with absolute value. This is a very basic absolute value function right here. And what this says is if I put -2 in here, what's the absolute value of -2? Well, it's +2. What's the absolute value of -1? It's 1. What's the absolute value of 0? Well, it's 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So let's plot those. -2, +2. -1, +1. 0, 0, 1, 1, 2, 2. And this one, it doesn't have a curve to it. It's straight. Both of those are straight. It's called it looks like a V. Whereas the parabola looks like a U, this is a V. And this one, because the number in front of the absolute value is positive, it opens up. Here we have a negative in front of the absolute value, which you can probably guess what it's going to do, but let's go ahead and take a look. Now this is a little bit trickier. If I put -2 in for x, I want to multiply first. 3 times -2 is -6. Then you have the absolute value bars. The absolute value of -6 is +6. But then you have this negative out front. That's like a -1. So -1 times +6 is -6. -6 plus 5 to finish up is -1. I'll do one more of those. -1. 3 times -1 is -3. The absolute value of -3 is +3. But then you got to multiply that by -1, which is -3 again. -3 plus 5 is 2. You can see the rest of the x values there with the corresponding y value. When I plot that, because the number in front of the absolute value was negative, it's going to open down. And it's still got that V shape. So the shapes of graphs of functions, just to recap. A linear, which was this equation here, or function here, is a line. A quadratic, x squared shape is a parabola. It's a U, and the absolute value shape is a V. 3 additional types of functions. We won't use these as much, but you should know what they kind of look like. This is a cubic function. So x to the 3rd power, you can see it kind of goes up, flattens out for a little bit, and then goes up again. Square root functions, they have a starting point and then grow and kind of plateau. And then cubed root functions have that shape right there. We're not going to spend a ton of time on those. The main 3 that you're going to want to know are linear, quadratic, and absolute value. And that concludes lesson 1.